Uh, Good evening, everyone. So today we'll be discussing about contest 464, the second question. So now first let us understand the problem statement. See, you will be given an array called nums. All right. Let us take for example 1, 2, 3, 4. The size is 4, and they will give you a k value. Let us assume that the k value is 2. Okay. So what is your aim is you need to group the elements inside this array such that the formed groups will contain exactly k number of distinct elements. Okay, so what I mean to say is, see here, for example, let me group 1 and 2. Okay, so there are how many distinct elements? 2 distinct elements. Okay, again, let me group 3 and 4. How many distinct elements do you find? 2. So like that, you need to group them such that you will have k number of distinct elements everywhere. Okay, now it's not that simple as you see. Let me take one more example. So let me have another array 3, 5, 2, 2. So if you observe, can I let me take the k value. So let me take the same value k equal to 2. Now how will you group them such that there will be 2 distinct elements in each group? So the first grouping that you can identify is, maybe let us take 3 and 2. Again, see, it's not a rule that you have to take continuous elements, so you can consider non-contiguous elements also. Okay, so 3 and 2 belong to one group, and 5 and the remaining 2, okay, see, this one and 2 will belong to another group. So these are the groupings. So what do you observe? See, try to understand the point. We want distinct elements. All right, distinct elements. Now the biggest enemy of distinct elements is duplicate elements. So when does the problem arise? The problem arises only when there are duplicate elements. Okay, so this is our target. We have to check for duplicate elements. Now understand the maths here. Let me have an array of size n. Okay, now I have to ensure that I have to divide this array n such that I will have k number of elements in each group. Okay, and see, incomplete groups are not allowed. That means one group will have k elements and then another group will have less number of elements. No, that will not be allowed. So the first thing that you observe is, if n, okay, if n is divisible by k, okay, if n is divisible by k, only then you can perform this task, right? You can divide them into groups and then ensure that there are k number of distinct. So all these tasks can be performed only if you have n percentile k equal to 0. That means the array size must be divisible by k, otherwise it is not possible. Okay, this is the first condition that you need to be aware of, because in the question they are asking to state whether it is possible or not. So if this condition is true, then we can move forward for further exploration. Otherwise we cannot. Okay, so else return false. Okay, now, so if n percentile k equals 0, does that mean it is definitely true? No, because there are some more conditions we have to check. See, I told you, right, we have to check for duplicate elements. So what is the logic of duplicate elements? Okay, let me explain you. So the first point is, as I discussed in the previous page, we will have, see, one group will consist of k distinct elements. Okay, so one group will consist of k distinct elements. So that means in total we can form n by k number of groups. Okay, is this clear? See, each group will contain k number of distinct elements. Okay, how many elements total we have? We have total n elements. Okay, so therefore we can form n divided by k number of groups. Okay, now see, if you have n number of n by n divided by k number of groups, then you observe this thing. Let me take the number of groups is equal to 4. Okay, just for some time. Okay, let us assume that the n value given is 8 and the k value is equal to 2. Okay, so assume these values. So there are 4 groups. Okay, who is our enemy? Our enemy is duplicate elements. Okay, so let me have an element in the array called 3. Okay, so let us suppose the number of times 3 occurs inside the array is 5. Okay, now let me draw the groups like this. Group 3 and group 4. Okay, now try to understand this element 3 has a frequency of 5. That means it occurs 5 times. Now can I ensure that I can put these 5 threes into these 4 groups such that there will not be any duplicate inside any of the group? No, I cannot do that. See, for example, try to place. I will place a 3 here. Okay, I will place a 3 here. I will place another 3 here. I will place the 3 here. Okay, so how many 3s are over? 4. Okay, but one more 3 is remaining. Where should I place? If I place here, okay, if I place here, this will become a duplicate. This is not allowed according to the given problem statement. So you should not do this. Okay, for example, let me cut off from you. What if I place it here? No, this is also not allowed. Why? Because they are not distinct elements. See, they are not distinct elements, right? What did the problem statement tell us? They told that you need to ensure that all the elements in each group must and should be distinct. So these are not distinct. So what I can tell you is, see, if frequency of any element inside the array, okay, observe this, frequency of any element inside the array is greater than I'm writing down number of groups. Okay, so if the frequency of an element within the array is greater than the number of groups possible, then definitely we have to return false as the answer. Okay, and I have explained this clearly because you cannot divide an element having higher frequency into the groups formed. Okay, it will definitely lead to formation of duplicates like this, and this is not allowed. So we have to return false. Okay, so and if this condition went false for all elements, then we can return true, and we can definitely say that we can divide the elements into distinct partitions. Okay, I hope this is clear. I will show you the implementation for this. So this will be the implementation. See, as I told you, the first check that we are going to do is if n percentile k is equal to 0, only then we can proceed further for check of the duplicates. Otherwise we are going to return false. Okay, see, observe this. If this condition is false, I'm definitely going to return false. Okay, if this condition is true, see, what should you do? If this condition is true, you must construct a hash map. Why are you constructing hash map? Because I want the frequency. Okay, understand my point. You need to find out the frequency. For that you must construct a hash map. After construction of hash map, I am traversing over each and every element inside the hash map. Okay, and I am checking whether its frequency is greater than the number of groups. N divided by k means it is the total number of groups. Okay, and if this condition is true, then definitely the final answer will be false. Otherwise we can return the original value that is true. Okay, I have initialized it here.